Hello everyone and welcome to Grinds Online Ireland. I'm Tara and today we're going to be covering proof by induction using inequality signs. So our proof today is prove by induction that n factorial is greater or equal to 2 to the power of n for n greater or equal to 4, where n is a natural number. And as usual, our first step in proof by induction is to show that it's true for the smallest value n. In this case, the smallest value n is going to be 4. So if we substitute in 4 into the left-hand side, we're going to get 4 factorial, and that's just the same as 4 by 3 by 2 by 1. And we can put that into our calculator and we'll get 24. If we plug in the right-hand side then, n is equal to 4, we're going to get 2 to the power of 4, which is just equal to 16. So from these then, we can see that the left-hand side is indeed greater than the right-hand side. So we know it's true for n is equal to 4. Our next step now, which is a really important step later on, is going to be assume it's true for some number k. We don't know what number k is, but we're just going to assume it's true for n equal to k. So if we substitute in k now in for n, we're going to have k factorial is greater than or equal to 2 to the power of k. And we know this is true. Our next step is going to be show it's true for n is equal to k plus 1. So if we substitute in k plus 1 in for n, we're going to get k plus 1 factorial is greater or equal to 2 to the power of k plus 1. And what I'm going to do now is I'm going to call this left-hand side here A, and I'm going to call this right-hand side here C. So we need to show that A is greater than C. We don't know if it is yet, but we're going to have to prove it. And this is where we kind of come down to our next step here. Now we come down to our part 2, and what I'm going to do is I'm going to write my part 2, assume my n is equal to k here again. And the trick here is to get this left-hand side to look like that right-hand side, or that left-hand side on top of the A is greater than C. And the key formula, guys, you're going to have to remember here is k plus 1 factorial. Another way to write that out is just k plus 1 multiplied by k factorial. So to change this k factorial into k plus 1 factorial, to turn it into a, all I have to do is multiply it by k plus 1. But if I do that to the left-hand side here, I must also do it to the right-hand side. So I can change, if I multiply both sides then by k plus 1, I'm going to get k factorial multiplied by k plus 1. That's going to be greater than or equal to 2 to the power of k multiplied by k plus 1. So now that we know, and we can rewrite this side, of course, as just k plus 1 factorial is greater or equal to 2 to the power of k plus 1. So in this case now, guys, we know a is on this side, and let's call this side here b. So we know a is definitely greater or equal to b. So then, wouldn't you agree, to show that a is greater than or equal to c, we need to show that b is greater than or equal to c. Because in that case then, if b is greater than or equal to c, then a must be greater than or equal to c. So our next step now, instead to prove that a is greater than or equal to c, we need to prove that b is greater than or equal to c. So that means we need to prove that 2 to the power of k multiplied by k plus 1, that's going to be greater or equal to 2 to the power of k plus 1. So if I write that again, we're going to have 2 to the power of k multiplied by k plus 1, and we need to show that this is true always when k is greater than or equal to 4. So if I just go ahead and multiply it out maybe and see what happens there, we're going to get k multiplied by 2 to the power of k plus 2 to the power of k. That's going to be greater or equal to 2 to the power of k plus 1. Now, maybe I could multiply this, or I can rewrite this part here as 2 multiplied by 2 to the power of k from our indices rules. So now our equation becomes k multiplied by 2 to the k is greater than or equal to 2 multiplied by 2 to the k. And if I bring that over, what we're going to get is 2 multiplied by 2 to the power of k plus, or sorry, we'll get minus then, because it's 2 to the power of k minus 2 to the power of k is greater than or equal to 0. And I can factor out 2 to the power of k there, so I'll get k plus 1 is greater than or equal to 0. Is this always true for k is greater than or equal to 4? Well, that should be a minus. It is, isn't it? Because if k was 4, well, this part will be 3 and this will be positive, so it will be greater than 0. If it was 5, this part will be 4, this part will be 2 to the power of 5, and it's always greater than 0. So we know now that this is true. So in that case, if we know that this is true, then this must be true then, and b must be greater than or equal to c. But in that case, if b is greater than or equal to c, then we know that a must be greater than or equal to c from down here. And if a then is greater than or equal to c, what we did was we just proved that it was true for n is equal to k plus 1. So now that we know that it's true for k, and now that we know it's true for k plus 1, we know it's true for any k, and we can say a rolling proof is formed. And from that then, we've proved by induction that n factorial is greater than or equal to 2 to the power of n for any n greater or equal to 4.